Okay, these are questions 9 and 10 from pretest 4. And inequalities, again. And going to use our technique we've been talking about in all these videos where we remove the inequality and turn it into equality, right? And then solve the equality. But first, anytime you have a rational expression and the rational expression has a denominator with a variable, you want to be very wary about that. We mentioned that when we were talking about rational expressions in Unit 2. And right here, you want to note that x cannot be 1, okay? Because 1 minus 1 would make a 0 in your denominator, so we're marking that, and we're going to be aware of that. Now, if we change this to an equality, treat this as if it's a proportion, I suppose, and then solve by cross multiplying, and we get 1 equals 1 minus x. Bring the 1, which is on the right, over to the left-hand side by subtracting it. We get negative x equals 0. So our solution is x equals 0. We put the 0 solution on the number line right here, right? And we put the 1, which we determined was not in the domain of this expression, also on the number line. So see how critical that is. When you have numbers that are undefined, which are not part of the domain, you have to account for those in solving the inequality. Now, from there, if you test numbers, for instance, if you were to try a number like x equals 2, just to demonstrate it, we'd have 1 over 1 minus 2, and we would be questioning, is that greater than or equal to 1? So you'd have negative 1, is that greater than or equal to 1? Right? Because 1 minus 2 would be negative 1, you'd have 1 divided by negative 1, so this side would become a negative 1. Is negative 1 greater than 1? That's false. That's not true. So numbers in that interval do not work. Whereas if you tried a number in here, a half or 5/10, whichever you prefer, you'd find out they work. Now notice the left-hand side of the interval is included because it's okay for x to equal 0. Notice we have the equality right there, so that 0 is acceptable. But the 1 was the result of a number that's not in the domain of the expression. 1 over 1 minus x doesn't exist when x is 1. So that side of the interval is excluded. And then if you tried a number less than 2, less than 0 rather, a negative number, you'd find that interval won't work either. Right? Number 10, finally use this same technique again, inequality to equality. This time no numbers are included, there's no equality under here, so all of our any solutions we get will be excluded, the circles will be open, right? But it is noteworthy that we also have an issue with the number 1, because if x is 1, 1 minus 1 will make a 0 in the denominator, and so we're going to want to have that number be included on our number line. From there, what we did was we think of it as a proportion again, just as we did in 9. Cross multiply, get x squared minus x. When you do the extreme cross, x times x minus 1, you get x squared minus x, and you get a 2 when you do the means, the 1 times the 2. We see the quadratic equation, and so we get one side to 0. We move the 2 over by additive inverse. The factoring is really easy. It's x minus 2 and x plus 1 as factors. And then you set each factor equal to 0, and you get x equals 2 and x equals negative 1. And don't forget, we also had x equals 1 as an issue. So we put those numbers, negative 1, 1, and 2, on a number line. They all are, as we mentioned, open circles. They're not included, right? And then when you test the intervals, for instance, when you try x equals 3, when you try x equals 1 and 5/10, when you try x equals 0, when you try a number below negative 1, like x equals negative 2, you're going to get a true condition. You're going to get a true condition. You're going to get a false condition in here when x is 0. You'll get a true condition when x is 1 and 5/10, and you'll get a false condition when x is a 3. So those two intervals with x's over them will be excluded, and the interval from -1 to infinity and the interval from 1 to 2, exclusive, all those intervals will work. So that's questions 9 and 10. Please get back to us if you have any difficulties.